octal 8, decimal 10, and hexadecimal is 16. So in this, these are the four types here. One to another, we are going to be converting with a direct number as well as the fractional number. And before going to discuss this, you need to know about that what are the characteristics of this number system. Okay. So let me go for that. So here many number systems, so which are used in digital technology at present. So what are the common number systems where we are using in digital technology means one is the decimal, where is the base of the decimal is 10. Another one is the binary system. The base for the binary is 2. Bi means 2. Decimal, deca is 10. And the octal, octa is 8. Hexa means 16. Okay. These are the four systems. So please be concentrate on these. The decimal system is the number system that we used every day in our daily life. What are the characteristics of number system? The digits are consecutive. Consecutive means immediately the other number will come. So if you represent 0, immediately after 0, 1. After 1, 2. Like that. So that digits are consecutive. This is the first characteristic of numbering system. Other one is the numbers of digits, which is equal to the size of the base. Four different numbers are there. Number systems are there. Each one is having a different base systems. For a decimal is a 10 is the base. Binary is 2. Octal is 8. Hexadecimal is 60. Like that. And whereas here 0 is always the first digit. Not by the 1 and not by the 2, like that. So 0 which may comes in the binary, digital, binary, decimal, octal, hexa. In all these, first digit is the 0. All the number system, first digit is 0. Next, so the base is never a digit. You may observe that for the case of a binary, what is the base of the binary? 2. So that is not a digit. Okay. For octal, 8. 8 is not a digit. Never a digit. Base number. Next, whenever if you add 1 to the largest number, the sum of 0 as well as the carry is going to be generated. In case of result, while you are adding any number to the digits here, largest digits here, you may get the sum as well as the carry also. Underline this, sum and carry, S and C. So whereas the numeric values which are determined by the implicit positional values. Position, what is the position of that particular digit which may gives. So number based conversion. What are the types are there? So how we are going to converting these numbers into different number systems. So how many types are there? In this slide, we already represented four types: binary, decimal, octal, hexa. So this may be into different systems. How many number of systems you can easily convert? Binary to decimal, binary to octal, binary to hexadecimal. Okay, that is the first one. Second one is the decimal to binary, decimal to octal, and decimal to hexadecimal. So decimal base is 10. You are converting into base 2. Base 10 number into base 2. Base 10 number into base 8. Base 10 number into base 16. Or else base 2 into base 10. Base 2 into base 8. Base 2 into base 10. Base 8 into base 2. Base 8 into base 10. Base 8 into base 16. Base 16 into base 2. Base 16 into base 10. Base 16 into base 8. Okay, now. So these many types of conversions are there. And what are the methods you are taking? How you are going to convert these numbers into different systems? So in decimal, decimal to binary, decimal to octal, decimal to hexadecimal. For octal, octal to binary, octal to decimal, octal to hexadecimal. Whereas finally, hexadecimal to binary, hexadecimal to decimal, hexadecimal to octal. So these many number systems are there where we are going to convert these. So see here number system. First is the decimal system which may use the symbols. Symbols is nothing but digits. For 10 values. Decimal system which may includes 10. How many? In characteristics itself, we already discussed that 0, which is the first number for all the systems. 0 is the first digit for all the number system. So that you need to consider, you may be considered while you are going to go for the different number system. So what is the digit here in decimal? 0 up to 0 to 9. That means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many total numbers are there? How many total digits are there? 0 to 9. Count it. You may get 10. So that 10 is the base for the decimal. Got it? Next is the binary system. Binary means by two values. 0 is considered consecutive. Okay. After 0, what may comes here? 1. That's it. Binary means only 2. 0 is the first one. Consecutive other number is 1. So by considering these, what you may get here in the binary system, what are the digits are there? What are the two values are there? 0 and 1. Next is the octal system. Octal means 8. So from 0 starting, what are the consecutive numbers? After 0, 1, 2, 3, 4, 5, 6, 7. Count it. How many numbers are there? 0 to 7. Count it. Total 8 numbers. Next, last one is the hexadecimal system. Hexa means 16. How many values are there? 16. Count it. Consecutive numbers from starting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 in hexadecimal system, 10 may be written as capital A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F. Okay. So, and also, if you want to represent any number, no matter how large or how small, you can easily represent. Okay. Next, decimal system. So, the decimal system, which is composed of 10 numerals or 10 symbols. These 10 symbols which are 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. By using these symbols as a digit of a number, how do you express this? 3501.51. So, write it down. Left side portion is the most significant digit MSD. Right side is the LSD. Least significant. Middle point is a decimal point. All are digits, not only a 0. 3 is digit, 5 is digit, 1 is digit. Okay. Whatever you may consider, all are belongs to digits. So left one is the MSD, most significant digit. Right one is the least significant digit. Next, binary, which is also called as base 2 system. Binary system is also called as base 2 system. So the binary number system, which is used to model the series of electrical signals, computers use to represent information. Which one is using here? Computer using these electrical signals to represent the information. For example, if you want to send an image or draw an image or copy an image, or if you want to do some calculation, that means summation, subtraction, by using these different decimal numbers. But how the system is going to be taking all these input values? You are giving as a image, you are giving as a number, you are giving as a data, some text you are typing. But how this system may consider or may taking all these means, which may converted into a small text, that means which may be converted into a electrical signals to a digits. Okay. So like that it is going to be converting internally by the processor, microprocessor. So here what is the 0? What do you understand from the 0? Means 0 is the low state. 0 is the no signal. 0 which is in off state. Okay. So here that is the case for the 0. So what is 1? 1 is on state. On state. What is 1 means on state. I state. 1 is I state. So 1 represents the presence of the voltage or in on state. Next is the binary system. The binary system, which is composed of two numerals, uh, which are symbols as a 0 and 1s. By using these symbols of digits of a number, you may express so 1101.01. Okay. So here, not like a, you should not be read like a 1101. Okay, this is not a digital number, digital system, sorry, decimal system number. This is a binary number system. So that this is a binary number. How we are going to read out this binary number means here 1101.0. Like that you have to read out. Not to by read as a 1101.01. Getting my point? So if you be considered it is a 1100 thousands considering hundreds and 10,000s considering ones considering miss. So that that is not correct. That is not suitable for this system here. Okay. So if you read like that, it may be considered as a decimal number. Getting my point? So in binary, you may be expect as a like as a read. You may read or express like a quantity. That means one means one, zero means zero. Okay. So that 1101.0 like that. So here also left hand side is the most significant bit, right side is the least significant bit, and the central one is the binary point, where point is the binary point. So each one will be treated as a bit here. Got it? What is the numbering scale? So for binary, base is 2, decimal base 10. So if you consider 0 means for a 0 decimal number, how we are going to represent the binary digit means 000. Whether it is 3 zeros or 4 zeros, whatever it may be. Final class, in final class, I will tell you how to remember all these things. Next one. First is the so decimal number is 001. That is binary. For second decimal number, 010. For third, 011. 4, 100. 5, 101. 6, 110. 7 is 111. This is the highest. So powers may be represents. What are the powers? 2 power 0 is 1, 2 power 1 is 2, 2 square 4, 2 cube 8, 2 power 4 16, 2 power 5 32, 2 power 6 64, 2 power 8 2 power 7 128, 2 power 8 256, 2 power 9 512, 2 power 10 1024. That is not written here, I am telling. Let us consider a decimal number quantity. How to represent the positional number? How you are saying that this is a 3501? So why? Because of this is a decimal number. Okay. Decimally you are representing by considering the base is 10. You are representing a number 3501. Okay. So let you go for this binary number. That is 1 is 1 into 10 power 0. Left to right, the power should be increased. If it is not a fractional number, left to right, uh, so sorry, right to left. So right to left, it is increasing the value, power value. 1 is right side, 0 is 5, 3. So power values, which power? Why? Because of this is a decimal number. So the decimal number base is 10. So the power is also going to be increases. Okay. So 1 into 10 power 0, 0 into 10 square, 5 into 10 cube, 10 square, 3 into 10 power. So 10 power 0 is 1. Whether it is 2 power 0 is also 1, 8 power 0, whatever the number power 0, any number power 0 which may be 1. So like that 5 into 10 square means 5 into 100 is 500. 3 into 1000 is 3000. By adding all these, how much you are getting? 3501. Okay. This is a positional number for a decimal number system. For binary to decimal conversion. So which is the easiest method to convert a binary number to its decimal equivalent, and which is used the multiplication algorithm. What method we are using? Multiplication algorithm. So multiply the binary digit number digits by increasing powers of 2 starting from the right. Next, third is the to find the decimal number equivalent. Sum those products. Next, binary to decimal conversion. So here binary to decimal. Example 1101. What is the base is 2? 1. So here also right to left. Right to left, how the base of the power is going to be increased. 1 into 2 power 0, 0 into 2 power 1, 1 into 2 square, 1 into 2 cube. 2 power 0 is 1, 1 into 1 is 1, 0 into 2 is 0, 1 into 4 is 4, 1 into 8 is 8. By adding, you will get 13. Okay. So 13 is the decimal number, 1101 is the binary number. So this is the simplest method where you are going to convert it into a decimal number. Next is the octal to decimal. Every condition we are taking at decimal number, binary to decimal, octal to decimal. Okay. How to convert any number into a decimal number? This is the method. So here also 7 is the base. Octal means base 8. 8 power 0. 1 into 8 power 1, 2 into 8 square, 5 into 8 cube. So by adding all these 7 plus 6 plus, so by multiplying powers here, you may get 7, 8, 128, 2560. By adding the summation, which may gives you here 2703 base 10. Next is the hexadecimal number systems. So hexadecimal number systems. So base of the hexadecimal is 16. By using the digits 0 to 1. And the remaining, which may be represented as a letters. That means A, B, C, D, E, F. A means 10, B means 11, C means 12. T means 13. Like, so this is the, you can see here, up to 9 is okay. So for 9 is high. So this is the case. Next is the decimal number quantity. Fractional number 0.581, which is the decimal number. The base of the decimal is 10. We know that. But here from left to right, the power value is also decreasing. How, sir? You can see. This is the 0. Let you say this is the 0. 1, 2, 3, 4, 5. Like the power is increasing. -1, -2, -3, -4. Like that. So G point is as a 0. Toward this -1, -2, -3. Like that. Powers are increasing, decreasing. Okay. So 5 into 10 power minus 1, 8 into 10 power minus 2, 1 into 10 power minus 3. So 1 by 10 is 0.1, 1 by 100 is 0.01, 1 by 1000 is 0.001. By adding all this, you may get this number, decimal number. Got it? Next 0.101, not 1, not 1. After point, digits only you have to read. 0.101. What is the base of this binary? Do. So here also 1 into 2 power minus 1, 0 into 2 power minus 2, 1 into 2 power. But you now need to consider it as a 2.0, 2 power 0. Already point itself it is considered as a 2 power 0. Okay? Point means 2 power 0. So point is considered as a 0. 0 into 2 power 0. 0 into 1. That means 0 only. That's why we are not considering the point here. After 0, what is the number? 1 is there. So that's why here the powers are going to be decreasing toward the here left to right. Right to left increase. So 1 by 2, 1 by 2 is nothing but a 0.5. 1 by 4, 0.25. 1 by 8, 0.125. By adding, this may be get. That means all the numbers, whatever the number systems are there, if you want to convert into a decimal number, your powers are whether it is which is a not direct number or else a fractional number. How the powers are going to be increasing, in which direction the powers may be considered as a decrease by doing this same process. The thing is that here what number you are converting into decimal number. So that base, that number base is also you only you need to consider 0.25 octal number. So if you want to convert into decimal number, octal means base 8. So 8 power minus 1, 8 power minus 2, 1 by 8. 8 power minus 1 is 1 by 8. 8 power minus 2, 1 by 64. So you may get the decimal. Next, F5. F. Letters are coming out here, not a digits, not a numbers. F5. F means 15. Hexadecimal. F is a hexadecimal number. So that in this case, hexadecimal. What is the base for the hexa? 16. So that's why here F into 16 power minus 1. F into a 16 power minus 1 means F means what is F? 15. You need to write down that what is A value, what is B value, C, D, E, F. A is 10, B 11, C 12, D 13, E 14, F 15, like that. If you remember these values, so you can easily substitute. So F means 15, 15 into 16 power minus 1, 5 into 16 power minus 2, 1 by 16. So like that, if you add a fractional number, then you can get the, what is the fractional hexadecimal equivalent of hexadecimal of a decimal number. You can easily get. Okay. Uh, Next, decimal to binary conversion. In previous condition, we discussed that every number which may be converted into a decimal, multiplied, you have been multiplied. If any decimal number is given out, if you want to convert into a binary or octal or hexa, you need to divide with that desired number, desired base number. Okay. 250 decimal number. What is the equivalent of the base number, binary number? So that you need to divide with 2. So first condition, 250 divide with 2. So 125. Any remainder is there? No, 0. Then again 125 divided by 2, 62. Okay, remainder is 1. Again divide with 2, 31. Remainder 0. Divide with 2, 31. Remainder is 1, 15. 2 15s are 30, remainder 1, 31. Next 2 7s are 14, remainder 1. 2 3s are 6, remainder 1. 2 1s are 2, remainder 1. Always bottom to top, the number you have to write. What are the remainders are there? So write it down. How many four ones are there? 1, 2, 3, 4, 5. 5 ones are there, 0, 1, 0. Base 2. This is the number. Whether it is correct or not, how you are going to check? This is the equivalent number. So see here. 1, 1, 1, 1, 1, 0, 1, 0. 2 power 0. 1. Okay. 0, 1, 2, 3, 4, 5, 6, 7. 1 into 2 power 7. 1 into 2 power 6. 0 into 2 powers. Okay, by adding all these, you will get 250. Okay. Uh, that means whether the number is correct or not. If you want to cross check, by using this method, you can easily cross check. Okay, now? Decimal to octal. Octal means divide with 8. Decimal to binary, divide with 2. 31 times, remainder 2. 8 threes are 24, remainder 7. So how to write this? 372. Whether it is correct or not, if you want to check it, 3784081 8 square. So 3 into 8 square plus 64 threes. 192. Add it 6, 7, 8, 9, 10, 0, 6, 15. Got it? This is a decimal number. So that if you want to cross check the values, whether the answer is correct or not, you can check it like this. Okay. So decimal to octal. Next, decimal to hexa. Decimal to hexa. 250. 250. You can check it. 16 15 are reminders 240. Remainder is 10. So that how you are going to write 1510. 1510. What is 15 in hexa? F. What is 10 in hexa? A. FA 16. Is it clear? FA. F means 15. A means 10. FA 16 means 16 power 0. So F into So this is the method. Next, decimal to binary conversion. Fractional. 0.4375. This is a fractional decimal number. How to convert into a binary number? Can you imagine this? So, which is the simplest method? You can go for it by multiplying 2. By multiplying 2 means 0.8750 you are getting. Okay. Next, again multiply with this, not to be considered 0. 8750 into 2, 1.75. Again, red color numbers are there. You should leave these and remaining numbers which should be multiplied until you will get 0. Okay. So leave this portion and whatever the number is there, multiply with this 2. What you are getting? 1.775. So that leave this 1.75 multiplied by 2. Again, we'll leave the 1.5. 1. That's it. So from top to bottom here. In previous binary to decimal, here a fractional direct number is dividing itself bottom to top. Fractional number top to bottom. Okay. So 0.0111 fractional. Please observe this. Next, decimal to octal. Octal means 8. Multiply with 8. Here also 0.34. Red numbers are there, no? Red color. Hexa. Multiply with 16. Next, decimal to binary. Multiply with 2. So you are getting this. So this is the estimation. So top to bottom 1100100001 based. Repeated number, if it is any repeatedly the number is going to be coming out, you need to leave it and up to a certain values only you need to consider. So base x to base y conversion. We can convert base x number into base y. X may be 2, 8, 10, 16. Y may be 2, 8, 10, 16. What are the steps are needed? Convert base x to base 10 decimal number systems. Then convert decimal number into base y. This is the case. Example 372.34 base 8 octal number is there. If you want to convert into hexadecimal, octal to hexa, what you want to do? Before fractional number 372, 2 is 8 power 0, 7 is 8 power 1, 3 is 8 square. After point 8 power minus 1, 8 power minus 2. At that time, if you want to do, you will get the answer 250.4378, which is a decimal number. Okay, which is a hexadecimal number system. Then 250 by 16. How much you will get? FA 16 you will get. Next, 0.4375 by multiplying with 16, you will get 0.7 base 16. By combining, you may get 372.34 octal number, which is nothing but a FA 0.716 hexadecimal. So like that you have to convert. So this is the method we have been learned. Today's class is that conversion of number systems. A decimal number, any number, direct number, or a fractional number. How do you convert? What are the methods you have to follow? You easily converted, and you have been pointed out that how to convert and how to note it down, how to follow these steps like that. You have been easily found. So this ends our today's class is that how to convert the number system. So by coming class, we should know about that how to add numbers, how to subtract a number, and one's complement. Okay, that we will discuss in tomorrow's. Okay, right. All the best.